students, this is the continuation of my teaching, which is the assumption of Hardy-Weinberg principle. Okay, moving on to the fourth one, which is no gene flow between population, migrate in and out of the population. Population is larger, no genetic drift. Individuals are mating randomly. Okay, moving on to the example, there are one example. Okay, you may see that. Okay, that's the example of a question is given, which is within a population of butterflies, the brown wing color, which is B. So B, capital B, you know that's dominant. Okay, is dominant over the white wing color. Okay, so white wing is recessive. Okay, so 36% of all butterflies are white. Okay, 36%. And using the information, calculate the following. We have to calculate the percentage butterflies in the population that is heterozygous. We know heterozygous is 2pq, which is this. Okay, heterozygous will be a capital B and a small b is equals to 2pq. Okay, white is recessive, means 2 small b. Okay, and it's 36% of butterflies are white. Okay, therefore we have to calculate that. Okay, that 36% over 100, which will give you 0.36. Okay, and q is equals to 0.6. So if q is 0.6, then p is equals to 1 minus 0.6. Okay, this one. Okay, 1 minus 0.6, the answer is 0.4. Okay, 0.4, and 2pq is 2, then you'll multiply them. So 2, so bracket 0.4, bracket multiply by 0.6 will give you 0.48. Then you multiply that 0.48 multiply by 100 to give you the percentage of the butterflies in the population. Okay, and part B is to find the frequency of homozygous dominant individual. Okay, homozygous dominant, which is 2 capital B. Okay, same, and the formula is P squared. This is the frequency of homozygous dominant. So P is 0.4 squared will give you 0.16. That's the solution of that example. Okay, moving on, the factors that affect genetic equilibrium. Factors that affect is mutation, recombinant during sexual reproduction, and genetic drift. Okay, those are the factors of genetic equilibrium. Okay, the diagram of founder effect and the diagram of bottleneck event. Okay, gene migration, immigration results in addition of new alleles in the existing gene pool and changes the allele frequency. Okay, that's all for our lesson notes this morning. Okay, I'll be moving on to the group activity work. Okay, the group activity work, I'll divide yourself students into 3 groups. Okay, there are some questions that has to be answered. Okay, it's 3 marks questions. Okay, 3 marks each. Here are the worksheet. We have to answer it. It's just a 5 minutes activity, group work activity, and it's just 3 questions. Okay, 3 groups. Okay, answer those questions, then we'll mark it at the end of this activity. You may start. It's a 5 minutes activity. You may discuss. Okay, all students has to be involved in those discussion of those 3 questions. Then we'll discuss it together in class. Okay, only 5 minutes